Hello everyone. Today I'm going to talk about solving nonlinear equation using MATLAB. Uh, this presentation is part of the course Numerical Analysis and Programming taken by Dr. Mango Song. So first of all, I'm going to talk about what is nonlinear algebraic equations. So you are all familiar with linear algebraic equations. So they have a degree of 1 and when plotted they will be linear in shape. So a nonlinear algebraic equation is an equation which has a maximum degree of 2 or more than 2. And when plotted, the graph forms a curve. And some examples of nonlinear algebraic equations are given here, like x square plus y square is equal to 1, which is an equation of a circle, and x cube plus 12x into y plus y square is equal to 0. And similarly, x raised to 5 minus x is equal to 20. So these all are nonlinear algebraic equations. And there are other kind of equations such as non-algebraic equations or transcendental equations. So what are these kind of equations? An equation containing transcendental function is known as a transcendental equation. So what are transcendental functions? Transcendental functions are functions that cannot be expressed in terms of a finite sequence of algebraic operations. So some functions can only be expressed in terms of an infinite sequence of algebraic operations. Such functions are examples of such functions are trigonometric functions, exponential functions, logarithmic functions, etc. So here I have given some examples of transcendental equations. Tan of x minus e raised to x is equal to 0, sin of x minus x into e raised to x is equal to 0, x log ln x is equal to cos x are some examples of transcendental equations or non-algebraic equations. So to solve these kind of equations, nonlinear algebraic equation and non-algebraic equations requires non-analytical methods because of their complex natures. So first of all, I'm going to talk about what a system of nonlinear equations are. So a system of equation is a set of two or more equations that share a common set of variables. So what is a nonlinear set of equations? A nonlinear set of equations or a nonlinear system of equations should be a system of equation where at least one of the equation should be nonlinear in nature. Now, how to solve such a system of equations? So we can write the equations of the form f of x equal to 0 and try to find x such that f of x becomes 0. This is also called root finding. So solving a nonlinear equations can be also referred as root finding. Now, how to do it? So we can find analytical solution for the nonlinear system of equations also, but some set of equations can only be found analytically, that too mainly quadratic natured nonlinear equations and so on. Other nonlinear equations will be very difficult to find analytically, and we will use numerical solutions. So what are some analytical solutions we can use? So one of the analytical solution is graphical method. So this method involves graphing the equation on a plane and finding the root by finding the point of intersection. So the coordinates of these points represent the solution of the system. And next is the substitution method. This method involves solving one equation for one variable and substituting it into the other equations and simplifying the system of equation to lesser number of variables. And other method is the elimination method. In this method, we will eliminate one variable at a time by adding or subtracting the equations, and we will reduce the number of equations to a single equation with one variable. So these are some methods used to solve nonlinear system of equation or linear system of equation analytically. here graphical method can also be used to find the approximate root or the initial guess for a numerical solution that we can see in the coming slides. So in the case of numerical solution, there are many kind of algorithms, and main algorithms are the bisection method, Newton-Raphson method, and secant method. And I hope some of them have been covered by others in their presentation. So I'm going to give a brief description of what these methods are. So bisection method is the method of finding a root of a function by repeatedly dividing the interval in half such that the subinterval will have the root. So as the interval becomes smaller and smaller, you will eventually find the root of the equation. Now the in the case of bisection method, the solution is a sure shot. If there exists a solution in between the interval, then we can find the solution, at least one solution of the equation. Now, in the case of Newton-Raphson method, it is an iterative method of finding the approximate solution to the equations. It utilizes the tangent lines to approximate the root of a function. Here, it is using the derivative of the function in the iterative method to find the approximate root. Here, it also uses an initial guess. Starting from that guess, it iterates to find the approximate root. Here, the solution is dependent on the initial guess, and we cannot confirm that the algorithm will converge or not. And the secant method is similar to the Newton-Raphson method. Instead of the derivative, it uses secant line between 2 points on the curve. Okay. Now, MATLAB has some inbuilt functions to solve nonlinear equations. And one of such inbuilt function is f0. So what is f0? F0 is a MATLAB function for solving a single nonlinear equation. Instead of a system of nonlinear equation, f0 solves a single nonlinear equation and gives the root of that equation. So it finds the root of a continuous function of one variable, and the syntax is given here. You can write call f0 function as some x solution equal to f0 of function comma x0 here. Now here the function is the name of the user defined function. You can define a function named fun and define the nonlinear equation in that function, and x0 is the initial guess. Now the algorithm that is inside the f0 is a combination of bisection, secant, and inverse quadratic interpolation method, and it was created by T. Decker. Now, how to implement f0? So, f0 can be used in two ways. Here, the x0, the initial guess can be a single valued or an interval. So, we are using these two methods in this. Here, the function is defined like this. Here, the function is sin x, and our initial guess is 2. And when we are calling the f0 function, it gives a solution 3.1416, which is the nearest root of the sine function. Now the next function is x square minus 4. Now we are providing an initial range 1 to 3, and the function is the solution for that is getting as 2, which is the solution in the range 1 to 3. And if you are giving a range in the negative range, we will get the -2 solution also. Next is solving a system of nonlinear equation. Instead of a single nonlinear equation, if you want to solve a system of nonlinear equation, MATLAB has an inbuilt function called fsolve. So fsolve, it is a MATLAB function for solving a system of nonlinear equations. It is a multivariable solver. And the syntax of fsolve is given here. This is the simplest syntax for fsolve. X solution equal to fsolve of function x0. Now here the function returns a vector of equation values, and x0 is a vector or a matrix. Now the algorithm inbuilt in the fsolve is trust region dot-leg algorithm, which is the default algorithm for the fsolve. The other is a subset of the trust region dot-leg, which is the trust region algorithm. And the other algorithm is the Levenberg-Marquardt method. Now we will look at how to use fsolve to solve a system of nonlinear equations. Now plotting two nonlinear equations with a single variable. Here I have given two equation, two nonlinear equation, y equal to sine 2x minus exponential of x, and y equal to x square minus 4. Now these two nonlinear equations plotted here to visualize how these functions look like. So here we have selected a range -3 to 3 with a step of 0.01, and y1 and y2 is written here, the two functions, and it is plotted using the plot function. And now we can look at the plot. So here is the plotted graph. So here y1 is the first equation and y2 is the second equation. And after plotting, you can see that these two equations meet at some points. So these intersections are the solution of the system of these two equations. So how to find these two equations? Now, as I said earlier, using graphical method, we can get an idea of where the solution lies, and we can use that to initiate our initial guess, actually. So here we know one of our solution lies in the range like between 1 to 3, and the other solution lies in the range -2 to 0, or we can take a smaller interval. Now the function is written here. Here both the equations are written. Here x of 1 is our x variable and x of 2 is our y variable. Now x0 is given 1 1 as our initial, so it's like x equal to 1 and y equal to 2. Now the solution, if we use fsolve of f comma x0, then the output will be shown as like this. Equation solved, fsolve completed because the vector or function value is near 0 as measured by the value of the function tolerance, and the problem appears regular as measured by the gradient. Stopping criteria details. So the x solution is given as 1.8291, and the value of the y is given as -0.6545. So we need the x value, which is the root of the equation, which is 1.8291, which is very close to what we have seen in the graph, so which we are expecting. Now we can also try to plot the first order optimality. So what is first order optimality? It is defined as how close a point x is to optimal. So by plotting this first order optimality, we can see how the value, we have the evaluation using fsolve is getting closer to the roots. Now the MATLAB code here we have added an extra command called options. But here optim options fsolve display ITER. So display ITER will display the iterative display or the iterative table, which I will show in the next slide. And plot FCN will plot the first order optimal. Plot function will plot the optim plot first order, which is the first order optimality. Now both the equations are given here. System of equation defined as f and our initial guess. And after calling the fsolve function, the output will give the solution. As we have given the range -1 and 1. So the solution in the negative region will be shown given, which is which we get as -0.8358. And from the graph, we can see that it is also what we are expecting from this system of equation. Now the first order optimality plot is shown here. Here we can see as iteration increases as from 1 to 2, 3, 4, 5, the first order optimality reduces gradually and reaches to near zero. Here it is given in the order of minus 14, 10 raised to minus 14. So it is very close to the root. And now the iterative display or the iterative table is also shown in the output. The iterative display is a table of statistics describing the calculation in each iteration of a solver. So it will display in each iteration what are the function counts, means the function evaluations, the mod of f of x square, means the value of the function square, and the norm of step, first order optimality, trust region radius, etc. So from this we can actually see that how the as each iteration how the system of equation is solved by the fsolve functions. Now in MATLAB you can also use optimize, which is an GUI interface to find the minimum and maximum function or a system of nonlinear equations, and so on. And there are some limitations to these fsolve function also. So you can look at some limitation. The function to be solved must be continuous, and when successful, fsolve only gives one root. So this is this limitation is applicable to all the numerical methods. Every numerical methods will give only one solution, which is closest to our initial guess or the region we have selected. And the next limitation is the default trust region dot-like method can only be used when the system of equation is square, that is, the number of equations equal to the number of unknowns. So when this condition is satisfied, then only the default trust region dot-like method will work. Otherwise, it will use the Levenberg-Marquardt method to solve the system of equation. That's all. I hope you are understood the solving the nonlinear system of equations. Thank you.